we should start now. I'm going to start my timer because I'm sort of known to never keep anything short. So yeah, you get to sleep tonight.
That's better.
Yeah. So yeah, I will have the formal who am I thingy in a bit. But I was thinking about talking about this today. So this will not be about Hackad or anything else. This will be about what I do when I'm actually working, not playing TV. So yeah, we will have a short introduction of where we all came from and what we morphed into with everything connected to ops in the end, and super agile and continuous everything. And then I'm going to talk a little bit about misconceptions that sort of presented itself or created itself out of our idea to sort of scale everything and just try to automate as much as possible, and what happens when we do that at scale in terms of security aspects. That's something we're going to look at. And then we're going to look at some vulnerability classes, because this is a security talk after all. And that will not present anything new. It will sort of be what's old is new again, and vice versa, like the common stuff. And then I had an idea, or it is actually the plan, to go through and like a super simple server-side request forgery attack and see what you can do with just like a super easy open redirect vulnerability, and see what happens when you have done everything correct, but you still end up failing. And who's to blame, more or less. And then I think we should wrap it up, like what could you do to sort of prevent it, and what are people doing in order to just continue having these kinds of vulnerability issues. That will be the thing that I will be talking about today. And I want to say that you feel free to interrupt me if you have any questions, but yeah, I'm going to say that and we'll see what happens. And yeah, and this is me. I work as a freelance security guy. I don't have a designated adult to manage me. I sort of do what I want to, and I tend to do offensive stuff. So I do mainly penetration testing. And I'm a part of a sort of a hacking community called Cure53 that focus on web penetration testing, more or less. And that's sort of what I do as well, but I sort of come in the orchestration layer with microservices and Kubernetes and everything that sort of runs in the backend, but it's sort of fed by a web-based pipeline, more or less. Yeah, that's what I do. Yeah, and I sort of like to hack stuff. I think it's funny. I started like a home automation project after the TV series thing, and I broke my IP cameras for real, just by accident. They're really shitty and cheap, but they are really like it's a really nice way to get into web security, because they are the vulnerability classes that you find in very cheap IoT devices are super simple, and like OWASP use shop is like harder than exploiting a cheap camera for real. The code quality is rubbish. Yeah, and I'm a professional provider of opinions. I have that as a disclaimer. Nothing I say is true, and yeah, I will say something else next time. And if you want to get in contact with me, you can find me at the homepage address there. Anyone knows what it says?
How do you pronounce it?
0x4a. Anyone? Okay, I'm done here. Yeah?
Jesper?
It's G, right? So it's cool, yeah. You can always trust Peter. Okay, but let's do this. So we sort of started here where we had a field where it was a guy who there was an entity sort of fixing the servers and connecting all the cables, and there was one guy writing shitty code, whatever, and shipping it to a monolith structure, maybe like a compiled binary and whatnot, like the good old days, like version control and everything. And we had security engineers that were more or less a blocking feature for people who were around in the early 2000s. It was like, no, you can't do anything. If you open a port in the firewall, everything explodes. So we had those. And we have the adults, of course, that sort of did things with papers and Legos and cool colors and whatnot, and sort of manage the whole situation. So what we had here was a compartmentalization. Is that even a word? I think so. So we sort of had an isolation factor here. Can you see that as well, right? So we had islands, right? It was really like you're doing this and I'm doing that and this one is doing that. And we had something called communication in between those, and now we're not talking about the actual communication that occurs between an application and network and whatnot. We had applications where we interact with each other and we agree or we don't agree, and that sort of pushes the development phase forward. And we sort of had in place controlling boundaries that were set. That we had a process, a way of working that sort of developed, right? And yeah, jumping a bit ahead. So this was basically the thing, right? So we have someone. Can anyone see this syntax? And if they can, they will get extra points. It's anyone? No? Network guys? No? Girls? No? It's a Cisco firewall. And then you have some Windows Server installation, and you had a checkpoint file. You had you did your thing. You did one thing, and you tried to do it good. And then this sort of happened, I guess. Yeah. So the rise of infrastructure as code is awesome. Like going for the cloud concept is awesome. You can do a lot with less. And you can scale and everything is nice and dandy, and we have nice frameworks that sort of, it gives us things, which is cool and really nice. But they bring one thing to the table, like the block things, that we have a section for IT security or a section for development. We have a section for management. We have a section for quality assurance, testing. All of those sort of defined processes and roles that were once occupied by human beings are now sort of in a giant, crazy mesh of infinity. Which is, of course, on one hand, super freaking awesome, but on the other hand, really bad for our security sort of state of things, in my opinion. You guys maybe think you're doing secure stuff all the time and everything is like Fort Knox. I come from a different perspective. I only do offensive security work. I never fix anything. I only break stuff. That's what I do. I write a recommendation, don't do this again. More or less, I'm not in charge of actually doing the fix. It could be that we find something in a source code and we add don't do this because this is bad because of, but we're not implementing an actual fix. We're breaking in, we're trying to break logical bugs that you have introduced either by a framework or a source code or whatever, and then we find a way to exploit that and then we move on. So I don't know, but maybe I have a new client every week more or less, and I do a lot of penetration tests in this realm. And this is sort of something that I see every day that I'm going to share with you guys here, and what people tend not to do. And so this is a cloud native thing and an OWASP thing. This is perfect. Yeah?
IntelliJ.
Yeah?
Do you have an example?
No, not here. I just needed to please everyone.
All right.
So that's why IntelliJ is there.
I was just really curious about it.
The thing is, I actually use VS Code, and I'm sort of an open source guy, but I really like VS Code. It's natively on Linux as well, so I really like that IDE though, which it's weird for me, I guess, to be a Linux dude, but yeah. That was a side note, by the way. That can happen a lot. That's how I work. How many in here are sort of aware of these three vendors here? I guess a lot, right?
I've heard about one of them.
This is good. This is good. Has anyone heard about the shared responsibility model? One, oh no, that was just, you were super fast and the other one had some latency. Yeah, that's good. Does anyone know the shared security responsibility model? Have you read it?
Yeah.
Which one?
It depends what type of service you use, if it's infrastructure or serverless or...
Sure.
Yes.
Yeah, it's
played.
Yeah, it's a different thing. Like AVS has a resource per resource based shared responsibility model. Google has 1,000 pages of text. sort of referring to things. It's a big thing to read through. I haven't read it. The only thing I've read is what's sort of not included for me as a user. And when I hear people implementing like cloud, or they're migrating for a hybrid solution, or going from 100% on-prem to actually source everything they have in the cloud, one of the factors I tend to hear is that, oh, well, we have this shared security responsibility model, and that's something that we tend to, that's a good thing. We didn't have that before. But it's basically meaningless. It's built to protect the cloud provider, not the end user whatsoever. So we're left on, like, we see a top of the iceberg thing, and we're left to do all the hard work ourselves. So we need to manage our customer data. We need to see too that we have authentication schemas that are nice. They are built on features that are provided by the cloud provider, but we are the ones responsible for the integrity in our authentication flows. And yeah, we can go on forever, like the rise of federated authentication with SAML and OpenID. I saw when I got in here, like, yeah, it's integrated, but they are not taking responsibility that your manifests are actually correct and working. That's all on you. And that could be pretty bad. So, show of hands in here. Let's go AWS. How many of you guys have run stuff in AWS? Nice. That's the one I know best, so that was good. Cool, that was good. So AWS, how many features does AWS have?
More.
Right? No one knows. You can rent satellite calculation things. Have you seen that? They have a satellite icon where you can do things with satellites. Anyone tried it? Me neither. I have no idea what it actually is. And that's sort of the problem, right? So the service providers are so rapidly changing everything and implementing new features that no one actually knows how many features there are. And why is that a problem? Because everything is connected, as in the before picture, right? Because we have the metadata layer as our backbone, where everything sort of have to be agreeing upon a concept that is called delegation and metadata access, more or less. And the problem with that is that every feature set by us is controlled by this control plane. And we don't know the control plane. Pretty scary, eh? And then we enable like really cool stuff, like CloudTrail and Guard Duty. And we get a shitstorm of logs that no one looks at, but we're paying the bill. And we don't really know what we're looking for. So they provided us with ACLs, or they sort of provided us with signatures. You can look for this. How many people think that like the generic Guard Duty thing in CloudTrail is actually giving you something? Or X-rays for that, like for Lambda's example, for sort of visualizing what's going on in a microservice. How many here run Lambdas? That was not that many. Have you enabled X-ray?
No.
No, you just fire and commit, everything works. If something breaks, I run it on my computer and then everything is awesome. No, but it's like, we have developed a phase here where everything is automated at a provider that doesn't take responsibility for our implementation. Could be a problem, right?
But how is that different to before?
To before, yeah. Perfect question. So before we had a controlling factor though. So before we had a compartment that managed servers.
Yeah.
And we had a compartment that managed the local network maybe. And we had a firewall team. And we had some kind of adult involved that sort of hold everyone together. And now we have an automated pipeline that speaks YAML or JSON.
Yeah.
And does exactly what we tell it to do, nothing more. On top of an entity that we don't know what it is. It was something when you pushed your commit yesterday, it's something else today. And everything is controlled through a control plane that is more or less a black box. Yeah, there is documentation, but honestly, I can commit to say that the only time I read documentation is when something doesn't work.
But I'd say in the bad old days that instead of YAML you had email that was to be interpreted by a human in the other end.
Sure.
So that's not very stable.
No,
either.
sure. No. I'm not arguing that we're going to something that sort of provides a better way of life. I'm just arguing that the security concept of it is rubbish. It doesn't add any value. And we're going to look at that a bit later here as well. So, yeah, this is actually the next slide. So, yeah. This one is like, it could have been from the 90s. It's like the exact same thing. We're working with security. I've been working with security, I don't know how long, a long time. And this is like the only thing that we're talking about, that and passwords. It's like everyone is doing the same thing and everyone is focusing on security, but we find the same thing. How many in here are penetration testers? So there are a few though. Not that many though, that's sad. Then my argument will sort of fall short when the statistics is against us. But me as a penetration, I tend to see the same kind of vulnerability classes over and over again. Would you agree, you guys, who are pen testers here?
Absolutely.
Yeah. So we're fixing a cross-site scripting. Yay! And then we're coming back next year. We find a new cross-site scripting. Yay! And then we find a SQL injection. Yay! And then they go to NoSQL. And then we find a NoSQL injection. Yay! So what is going on here? Nothing. We're just putting holes in the leaking ship, right? We're not actually doing anything about it. So we're finding the same vulnerability classes all over again. So what old is new and what new is old. And I'm starting to get tired of it because it doesn't like, of course there is challenges like the attack chains nowadays. Like, okay, well, you can find like really nice like one-point shoot or remote code executions, of course. And they are really cool and you feel like a superhero a long time after you find that one. But nowadays the attack chains tends to be a bit longer. It tends to be like multiple steps. But that's like the only thing, in my opinion. And what do I know? So now we're actually arriving at the cool stuff. That was my rant about this. I'm going to check time. Time is good. Time is good. So this is what I'm going to go through, like the anatomy of a really common web vulnerability and what impact it has on our AWS instance in this case. So Grafana, has anyone not heard of Grafana? It's okay not to know. No, perfect. Good. EC2 instances, pretty fair and square as well, right? Rent your virtual server in the cloud. The bootstrap, what does the bootstrap do? Anyone? So when you press start launch instance, there is no genie running down the basement, pressing start and run up again. You're sort of executing a YAML file or a Python file that says to the server start and do this. So that runs almost every time you reboot, but not always. And that's the bug that we're going to look at later, which is also nice, but it's pretty undocumented, so people tend not to know about it. And then we have, of course, the magic shell, the longest one-liner in the world. This is all it takes. This small little line, it needs to be a Unix-based system, so you need to have Bash, of course. But not anymore. Windows has Bash as well. It's actually true. So it's actually a really nice one-liner. And there you see my command and control server as well, but that I don't care about that. Yeah. So what I'm going to demonstrate now in different amount of web penetration testers, not that many since there were 3 here, so I can assume that those 3 know their stuff. So I will not bore you about digging too deep into the Grafana exploit here, but we're going to talk about it anyway. So this one is, I took this one because it has a really nice CVE. You can see my nerd humor. So it's, yeah, whatever. Okay, yeah. So it is a unauthenticated full server-side request forgery. Anyone care to explain what a server-side request forgery is? So really quick, it's I, as an attacker, are able to do a request as the server. Not like as the server, as an entity, as a device. So in terms of AWS, is that a good or bad thing?
Bad.
Really bad thing, right? Could be a bad thing. Right. I do agree. It could be, yeah. And it's it's like a really common vulnerability class in my line of work, like in the web field. So in this case, there's a really, Grafana is widely deployed, and you're creating an account, you have a dashboard, you can log in, you can do a lot of cool visualizations, like there are nice dashboards with pie charts, and you have statistics over IO loads. It's really cool, and it's really commonly adopted, right? So in this case, there was a bug in the, because you need to have an avatar, right? You need to have a cool picture, like showcasing your cool stuff inside of your dashboard. And then you can upload a file, and that file could contain a picture, right? But they sort of whitelisted a bunch of common ways people sort of store their pictures. So they whitelisted Imgur, they whitelisted Facebook, they whitelisted WordPress, I think. And how did they do that, one might ask? And one could. They actually implemented a regexp. Anyone here is a black belt in regexps? You're lying. No one is. It's dark magic. No one knows how it works. No one. And it always fails. It always fails. Like the most unexpected things happens with regexp. It's just like the invention that never should have been. It's crazy.
That's the definition of being a black belt.
Sorry?
No, that's the definition of being a black belt in regexp. That you know that you are creating a new problem. So
yeah, okay, maybe that was nice, yeah. No, but I think everyone here has sort of, there is this really cool page that I have in my bookmark, I can't remember what it is, where it's like a decompiler for regex. So you see, you sort of paste it and then it's just, it's really nice. What if there is a parser error there though? Everyone uses it. That and Stack Overflow problems. Okay, so that's one thing that they implemented, and it sucked, obviously, because you could bypass it, and I'm going to show you how. They have a parameter defined as D, that is a redirect parameter, and with some nifty tricks, we can actually fool the image upload to load a file that we control. That's sort of the vulnerability.
Did you have to be authenticated
Nope.
to the Grafana?
Nope.
So just...
Yeah, okay, to the Grafana dashboard, you have to have a dash, you have to have an account. Yeah, that's correct.
So you actually have to be logged
Oh, let's
on.
see. I think the function is actually unauthenticated. You can actually reach the function in the URI, but in like the common use case, the right use case for it was that you supposed to upload it when you created your profile.
Alright.
But it is an unauthenticated thing, more or less. So what we're doing here, this might look as gibberish, but what we're doing here is dash-brokenserver.sc. We are sort of using the the highlight is really shitty here, but yeah, we're using the Imgur parameter, and we are using that in order to redirect it to my server where I have my awesome redirect.php, because PHP is that's like the fastest way to write shitty stuff. And what's actually happening is that we're creating an open redirect, and the redirect.php file sort of redirects ourselves, helps us to reach the metadata layer. You can sort of see it here. And you have some URL encoding, and then we get a 200 back with not so sensitive stuff, right? Yeah, and in this case, we're getting back the secrets from the EC2 instance here, and that's nice. Like that's like a server-side request forgery in AVS. This is happening, and in our mitigation method,
Disable metadata access?
yeah, or not disable it because you can't. You actually can't.
It depends on if you're running in a container, you're actually able to modify.
Oh, you can isolate it with an ingress or something, but you can't disable it.
In Kubernetes, you can.
Oh yeah, you can do anything in Kubernetes. That's actually true.
Even better.
The question is though, what breaks afterwards though? But okay, there is actually one mitigation you can do. Server-side request forgery has walked up the OWASP top 10 list since it actually arrived there. And what AWS and GCP have seen, or Azure as well. Azure is a different thing. We can talk about that over beers. And I work for Microsoft. They're implementing their own Kubernetes stuff. It will be awesome. A little bit further. They have a little bit more to do before it's done. Yeah, so the instant metadata layer. Yeah, they actually implemented something called instant metadata layer version 2. They have good imagination, and that's a good thing, because then you need to sort of get let's see if it is a token. So you need to do a request before you're able to query the actual metadata layer. So you need to have a better foothold. You can't do it through a server-side request forgery yet alone. But that's not a native function that is enabled by default. You have to do it afterwards. And that's something we're going to do in the wrap-up here. I'm going to talk about what we're not doing. So now it will just be what we are doing. And that tends to not be enabled by default, which is not very good. Because then we're able to query the metadata service as the server in this case. And then we get the keys. And with the keys, we can do things. Right? So now we have sort of arrived here. We got the keys. And then nothing is cool until we get a netcast listener to call home, right? So that's what we're going to do now. So we don't have a shell access now. What have we? We have a security, we have a key, we have a secret key ID, and we have a token, right? It doesn't really matter because we can just run our payload over and over again. So the session token, it will get, it will reach its end of life pretty fast. But we can just do it over and over again. So we have more or less persistent access to that specific EC2 instance.
Do you get to refresh tokens through EC2?
No, you have to like push the payload again to get a new set of it. But then again, if you are a bit nifty, you can script that, of course. But here we don't. So what we want to do is create a basic shell that pings us, that calls home. That would be awesome. Like the server-side request forgery could be patched. They could just upgrade Grafana and everything is over. That sucks because we spent a lot of time finding this vulnerability, so we need persistence in order to gain the big bucks. So we want a small one-liner. This is a really nice shell that I tend to use always. We can go into why it's 1990s later, or in the 9001 and 9008. That's a really neat trick. I can show you later. We have problems though. AWS uses a bootstrap. The bootstrap we talked about before is instrumenting and building the instances when?
Boot up almost?
Yeah, boot up and when you build it. But then you can think that if you turn it off and turn it on again, will it run the bootstrap again? No. It will not run the bootstrap again. So we have a problem. We need it to run the bootstrap again because that's the only attribute that we can sort of manipulate. And I know how you can manipulate the bootstrap sequence here. Is there a field that you can do anything with in AWS? That would be awesome. I haven't thought about that. Maybe that could maybe work.
I don't use AWS.
Like, would you have something called use data? So you have a use data parameter that you can actually put stuff in.
In CloudInit.
Yeah, it's a part of the CloudInit thing, the bootstrap thing. So, but that's not the solution either. But the solution is a pretty unknown but documented feature. Is the bootstrap is base64 encoded because everyone knows that base64 encoding is good. But that is actually a good thing here because it sort of keeps everything aligned. But you can create a MIME file, like a multi-part file. Everyone knows the file type where you sort of define multi-parts in a file. If you have a bootstrap that is multi-part, it will always run when you start the instance, if you tell it to. And we can do that. So we have the key. We create a profile called EC2 and we add our keys and our tokens and our region. Maybe we don't know the region, then we have to do some pretty low orbit enumeration to get like which region is the server actually in. It's pretty fast. It's not that many, and it will give us that read write. And then we need to add and modify the user attribute, so user data attribute, in order to be able to sort of do this. And this is done by this little syntax. So what we're doing here is that we're saying we want to modify the instant attribute with the instant ID here. It's fake, so you don't have to worry. And use the file shell.sh, and that's the base64 multi-part message that we talked about before. That will put itself inside of the bootstrap. Then we wait. Now, this doesn't execute right away. So this is not like the awesomest hack in the book. The instance needs to be rebooted. It needs to be start or stopped. And that is not like if you're doing a default EC2 instance, an instance is not able to restart itself. You could maybe, if you have built a delegation or a assume role or assume policy or inline construct in your IAM, that could be the case. If you sort of, that's a whole different talk though, how EAM is not working. But yeah, so you could that could be possible. You could try that as well. But in that case, we just wait to maybe the sysadmin is gonna do. Maybe you have a recurring job that saves states, perhaps. Like you're doing a snap and you want to validate the snap, and if it doesn't match what you think it match, you can pause it and respin it again. That sort of happens. So it's like a common behavior that EC2 instances tend to sort of rotate a bit. And when they do, we have injected a persistent payload, because with every reboot, it will connect to the netcat listener outside. Pretty neat. And then you have a persistent door in order to sort of start your post-exploitation activities within that VPC, or if it may not even be a VPC, or it could be whatever, right? So that's like a pretty common vector. Server-side request forgery somewhere, and then we reap the benefits of it. It could be an OpenStack, it could be Google Cloud Platform, it could be Azure, it could be whatever. It's existing everywhere, right? Yeah. Anyone has an idea? What now? No? Me neither. So everything was sort of implemented exactly as intended, right? I would have done it the same way. Like there is no, if you're reading, let's say you're going to read it, I don't think anyone would read the documentation, how to spawn an EC2 instance. That will not happen, maybe. Maybe, I don't know. I don't think so. But everyone in this sort of thing did their job. So there was one logic bug in one framework. It was a standard EC2 instance with no freaking cool attributes or delegation models or anything. It was just like a plain vanilla thing, right? And then, yeah, the sysadmin or the DevOps thingamajig did what they were supposed to do. And then we got a persistent shell inside of someone's AWS environment.
Well, they did give the instance IAM permission to change the instance attribute.
Yeah, but that's actually a native. You are actually permitted at changing the user data at runtime as an EC2 instance. It's a standard attribute. But you're not able to kill yourself. But you're able to change the user attribute. That's why you need a sysadmin to reboot the server. Or the workload to reboot itself. Yes, sir?
They expose the Grafana instance?
Yeah, you can go down that path, but it will not be pleasant for you.
But actually, why would you expose Grafana externally?
After this talk, we're going to do a showdown query to just see how many there are.
I fully understand.
We can do Prometheus, we can do Rancher, we can do Calico, we can do Istio, we can do whatever hip.io thing project that you want to. And we will find...
Before you actually brought up the question about should you really expose these kinds of services. So a problem is exposing services that you actually don't understand.
Yeah, you are correct, but then I will just raise you with the ultimate question. You're developing a web app. It lives in a Kubernetes cluster. It lives in an EC2 instance. Your move.
Or forward.
No, but the thing is, like, the problem is that it's not Grafana's fault.
No.
There will always be vulnerabilities in the things that we use, especially the shit that we build ourselves, because we are crazy.
But as a remediation for everyone here.
Don't publish your web apps, because they are not responsive anymore.
No, but perhaps don't expose all web apps directly.
So just the ones that are not bad.
No, at least the ones you build yourself you can expose.
I'm not so sure I'm following you here. Nope, don't agree. So the thing is here. This was exactly the thing I wanted to happen, because it's not Grafana's fault. This time, but next time it will be your fault. It's good that you're in the back because no one knows. So that's the thing, right? So what are the common denominator here? We're implementing frameworks to help ourselves that we don't manage. They get hacked because they are used a lot. So people will do source code audits and find vulnerabilities. And then they will attack those vulnerabilities at scale and reap the benefits. That's how it works. The bug bounty community has grown infinite since I started with security. That's how it works nowadays. But that's just me rambling. The same goes for an app that we develop. How many here have control? Node.js is something that I've started with. Holy. Like every time I log into that instance, there are like billions of dependencies correlating to security updates. We only need one server-side request forgery in a dependency package of 150,000 lines of code. The odds and the statistics is sort of against us here. And like we talked before, like, are we learning anything? Are we mitigating server-side request forgeries? Are we mitigating cross-site scripting? No, we find more of them all of the time. So we have super cool agile DevOps tools. We are super fast. We can automate. We have awesome tools, but still is not like security-wise. Meh. That's just my opinion. So yeah, and this was sort of the yeah. It doesn't really help. But enough rambling about that. What can we actually do? I think this was also the thing, like, what can we do? Nothing, goodbye. That's dark, but that's my sense of humor. So this is more or less what we talked about, right? That we will always have vulnerabilities. They will always be present. We will either introduce them by trusting someone, or we will create them ourselves, because that's how it goes. There is no secure code. Period. Did anyone saw this awesome hidden backdoor feature that was sort of released yesterday? Like find the bug. That blew my mind.
NPM.
Yeah. That blew my mind. Was it the NPM one? Yeah, maybe it was. Maybe we can talk about
upload the script.
Now this was only a character. This was like an empty character where they have put one, like there was in an open bracket where they defined one variable that's going to be attached to another one, and there was a space, I believe, and the space was interpreted by the parser as you could extend it and run whatever command you wanted as this. It is like, because it's super weird. It's just a space. Correct me if I'm wrong, but it's like, yeah, it happens, and we will always do that. So things will be vulnerable, things will be misconfigured. That's the norm, and we have to sort of act accordingly. And that only boils down to one thing, which sort of connects back to the old days. We need to know what we're doing. And we don't. Because we're doing everything. So we're sort of flatlined. The whole DevOps thing is that we have taken everything IT, pressed it into interpreter, more or less, like a infrastructure as code pipeline, a build pipeline, and we're doing everything based on someone else's thought about it. Like use Terraform, for example. How many in here use Terraform? Have used Terraform? Yeah. Do you use a linter?
Yeah.
Yeah. Which linter are you using?
TFSec.
TFSec is good. Chekhov is good as well.
Terraform FMT.
Well, yeah, sure.
Kind of.
Sure. But the thing is, with TFSec, we can take that one for example. It will only digest what's constructed before you, right? So is the Terraform template for AWS complete in a configuration-wise?
Of course not.
No.
But better than me.
Hopefully. But you're trusting someone else.
Yeah, but
you're not verified.
I actually try to do it the best I can, and then I run it. And
yeah, that's good. But the thing is, that is actually signature-based. So that would only be as good as a signature for that specific feature that you're. Yeah. So that's a lot of the cases like you see. Oh, they haven't even defined these. Yeah. They're here, but you haven't even defined them. Yeah.
But as Ivo said before, most of these tools are open source, and you mentioned just create a pull request if you need another room.
Yeah, perfect. No, but the thing is here. The thing is I'm doing here is like try not to shift blame. That we have to take responsibility for the things that we do, and in order to do that, we need to know what we're doing, like in full. So, yep.
Maybe I'm backing up a little bit.
No worries.
If we don't promote, if we I mean,
If it's just living,
no, we redeploy
yeah.
instead. So you redeploy a new version instead of your EC2 images, instead of actually rebooting them. If you're going to have downtime anyway, then
What does that mean in the sense? Is it like where are you?
I'm getting it from an AMI, let's say.
Yeah. So if you're using an AMI, and you're sort of integrating that one, then this will not work.
Yeah.
I know
this
you
is-
have the profile. Didn't you modify the profile?
Yeah, but it will not randomly be deployed without because the instance keys aren't allowed to kill itself or redeploy it. It has to be at Bootstrap.
I would attack sort of the premise underlying that, and I would say that it is inherently less secure to have pets than to have cattle. I mean, at that entity level. Then of course you discuss how does the cattle live, and then you get the pipeline, and then you get new attack surfaces. Absolutely, but simply at that level, and I was when you went through this, I was thinking about the AWS infrastructure that I've been working with, and I was exactly at that point. I would say that but if you have an instance that is long-lived, yes, you have a bigger security. If you had built like a what do they call now?
Say the Swedish word.
I don't know I forget what they call it.
No worries.
The auto-scaling groups.
Yeah.
That sort of maintains that assistance. The instance will not be, well.
And this is one.
Some of the types you choose will not even be physically or logically able to reboot at all.
Sure.
So you will be safe.
No, this is like not like the one hack to rule them all and in the darkness bind them. This is just one.
Yeah, exactly.
And it's super simple.
Yeah, but you can probably figure out what launch template you used and use the launch template to inject your user data. Because
Sure, that could work as well, but it depends on the leverage. So
Correctly done, the machine will restart a new instance when you do that, so you don't have to wait so much.
sure, that could be the case. I don't know,
Yes.
but what I do know is that almost everyone that I pen test don't do egress filtering whatsoever. They even allow me to use a DNS. So that's the thing. So if I have remote code execution, game over, period. I'm able to, through a server-side request forgery in the web stack, create a netcat listener on a server in the operating system's runtime to connect back to my service. What? So if you enable CloudTrail and whatnot, you're able to actually detect this. You're able to create egress filtering. You're able to do this. But we tend to don't do it. And it makes my life super, super hard. In the Kubernetes realm, a lot of people use Alpine. Anyone done any runtime or workload hardening for the Alpine image? Do you use multi-boot when you build your Alpine images? No. You run them as root. Because everything is nice and dandy, because we have a Kubernetes cluster that has an ingress, that has security controls. Sure.
Well, Kubernetes is actually insecure by default, and
Yeah, don't get me started. Don't get me started. I'm actually I'm a part of the organization that are, like, we are only 5 in the world that are allowed to send in requests for proposals when it comes to pen testing Kubernetes as a project. And that's a whole ballgame. It's like the thing that we had to produce in order to get there was a lot. But I can't take the credit. It was like a Curie 53 effort. But it's like, that's the whole point, right? But we get an idea that if we have a workload that is auto-scalable and everything works super nice, we're still in the end publishing it to the internet, even though it's through an ingress or whatever. We actually told you guys here that was my girlfriend. We actually told you guys that we're doing a server-side request forgery attack that pinholes the entire infrastructure. And that is the same if it lives in a pod or wherever, right? Yes, sir.
So you're talking about like CloudTrail and these things, and we talked a bit about X-ray and these tools that do that. And
Yep.
like, sure, we're collecting all this data, and we might be collecting logs or network logs or whatever. and you said, oh, but who's actually watching these things, or who actually knows what to do with them? Isn't this kind of the same kind of non-solution to the problem of, sure, we have CloudTrail, or we might have egress logs or whatever, but this is one issue out of 1,000, and how do we even fingerprint these types of...
Yeah. No, this is an excellent question, and that's, I think, is awareness, I guess. So sort of be aware of what you're exposing and where what is important for us, what is worth protecting, and don't trust anyone else to sort of help you with it. Like the era of antivirus and IDS and IPS is like, yeah, whatever floats your boat, but they all go to 11 and solves everything, but really, nope. So you sort of really have to know what you're protecting in order to build protections. That's just my take of it. So it's like, by just disabling the egress, my backdoor wouldn't work. If that is not able to call any IP address on the internet, it's broke, it can't work.
You said DNS as well.
Yeah.
So if you have DNS but not egress.
It doesn't matter. You can resolve the DNS, you can resolve the URL on your local machine, just paste the IP and get whatever you want to anyway.
But if egress is denied and you're able to resolve.
Yeah, but then I'm not able to go out.
You're able to go out.
No, I'm not able to go out.
Right.
You could, okay, well, of course. Let's say you build a DNS exfiltrating thing that you use ICMP with like a, but then again, then you should just have that. Like if that attacker happens, you should just buy that person a nice flower or something. Yeah. If they build an exfiltration thing.
Earlier you said that
that's also like
DNS, I was like...
That's a common case here, right? So when we're talking about this, we always tend to go like the complex, like we were talking about, yeah, this is like a one-liner to make a reverse shell. But what if you did, and it's like we sort of, the skill level of the actual attacker goes up immensely, and that doesn't happen because people are lazy. We're using the low-hanging fruit. I don't want to invest a lot of time in an exploit chain that is a gazillion hours long. I want to have it fast, right? But it's possible. But then again, if you're disabling egress calls outside of my AVS account, that will make it a lot harder. If I implement guard duty or CloudTrails to look for egress traffic or look for netcat is being spawned to a channel and calls out, it's a super easy thing to implement.
But this is just after the fact.
Sure.
A lot of this.
And this is just me telling you that this server-side request forgery is not something that I've been cooking on for 10 years. Yeah. This is something I see multiple times a week.
Yeah.
So, and the solution is not something brand new here. I think everyone here sort of agrees that if you can't connect to the internet, you can't get a remote shell. Go.
Isn't something kind of wrong in Amazon if an unauthenticated SSRF vulnerability?
One can think that.
Yeah.
But then again, we have a shared responsibility model.
Right,
so I, as Amazon, don't really care.
I think like in Kubernetes, you could run without any service accounts at all.
Sure, that will be helpful. But then you have a kube proxy, a kubelet. You have multiple factors that you could poke about. But then again, then you have persistence in the Kubernetes cluster, and it's not fair for Kubernetes to say that you can't do anything there because you're sort of in the cluster. Yep.
What's your opinion, maybe back to my question, but what's your opinion compared to like detection versus prevention methods? So for example, like hardening, setting up like read-only file systems, for example, to block someone like bringing in some sort of random binary.
But you can load it to memory then, maybe.
Yeah, I know, but like these types of things versus focusing on detection
like,
when things go wrong.
Like in the container ecosystem, like I don't think it makes sense to implement cgroup or AppArm or something like that. But I think it would make sense to, if let's say you're running an Nginx or something, it would make sense to build that container or workload as root and then drop capabilities when it's in runtime. Everyone knows this. No one does this. Or why not run distroless container? Why not? It's possible.
TLS is basically mostly the
yeah, but no one sort of implements mutual TLS or TLS at a scale in a production environment anyway. So it's like...
But you've heard about the service mesh industry.
Sure.
So they really try to get everyone to use neutral TLS.
Yeah, and that's a good thing though. But then again, that's like
neutral TLS is great.
Yeah.
But it's
and why is
so
that?
hard to implement.
Right.
So everyone who tries it actually just makes the cluster so much harder to maintain. So they stop.
It's opinion based, right? Everything you suck at is hard. That's like the whole thing. Like we develop because we're bad. Like we learn by doing wrong things. We learn by not succeeding. That's like the whole thing. And if we're doing the same thing, guess what? The same thing will happen all over again. And that's sort of what I'm saying. Like, it's a recurring thing. Yep.
So what do we need to do then? Do we need to
Yeah,
educate
excellent.
programmers or?
Actually, no, I wouldn't say that we should blame anyone. We should take our responsibility as a whole. So I think we should know our technology stack. And everyone, yeah, sure, we know everything. No, you don't, because you're implementing, you have a package manager, you have a dependency thing, you don't build your own modules, you use someone else's code. You have to know what that code is doing. And you need to have a process in order to maintain it. Everything that you build yourself needs to be vetted. And you don't have to buy it from a really expensive penetration testing firm. Just let your buddy do it. Check your stuff. Share. And help evolve together. And it's the same with security controls. They are there. There are no new ones. Like, adopt those that are there and those that make sense. So in this case, like, visibility makes sense. You can use Sysdig, you could use Falco, you can use Trivy, you could use Datahog, you could use Elasticsearch, you can use the Elk Stack. There is gazillion tools out there. But the only thing that you have to do before you start is sort of decide what is worth protecting and how do we do it as a whole, instead of just trusting the cloud provider blindly. That's my opinion. So this is not a solution talk. This is just like, if it runs, run. That's not the case. I've seen COPS clusters. COPS, everyone, yeah, the native stuff. It's a Kubernetes operations framework. It's like Minikube. Have you run it?
Please.
No. So you sort of, it's with the K. So it's just sort of one click and you have a Kubernetes cluster. Awesome. But it's not secure. But I see people run that in really, really, really big deployments. Like they have their whole business in a default cluster that is crazily broken from default.
Are managed clusters secure?
Managed, like the geeky, from GCP?
EKS, GKE, AKS.
So EKS, I haven't wrapped my head around EKS, to be honest. I'm not really sure what it is.
It's not.
It's like a Kubernetes thing integrated in the EM concept.
Yeah.
And this Elastic Container Repository thing is sort of connected somehow as well. I'm not really sure what it is. When it comes to the Google's version of it, it's a monolith, so it's a bit better, I guess. I don't really know. But they have capacities that AKS don't have, like shielded nodes, for example, that you sort of can isolate the worker nodes from the rest of the world. That, in my awareness, not EKS provide yet. But then again, Google has a head start on Kubernetes, right? There she is again. Sorry. Yeah. We can talk about this a lot more, I guess. Let's see, 53 minutes. That's good, though. Yeah, and I have some shameless plugs. We can talk about, I will be here during beers as well, but I have some shameless plugs. You have to watch this, but not like you think. You need to watch it at SVT Play. So all your botnets need to go and watch this at SVT Play so we can do a season 2. Because, like, if people watch it on television, not good enough. We need views on SVT Play, so that's what you're going to do after this talk. And then you should go here in June.
Yes.
I don't know the dates, but in
The 2nd and the 3rd June.
I have it designated all over me. And it will actually, it will be our 5th year anniversary, right?
Yeah.
2022.
Sorry, that's me.
Yes, we're a bit late.
So no, it's not a time traveling thing. Yeah.
Have you opened CFD yet for it? Or?
No, but it will be. Alexander left, but we're buying a CFP system because we're shifting focus. Yeah, but it's coming. And
Secure.
I have no idea. We're buying it as a service, so.
And then it's secure, of course.
With shared responsibility.
Yeah, right. And then you should listen to Second Sport Casting because that's a good place to go. And yeah, if you have something cool that you think that I would could be beneficial in helping out, just you will find me there. And I'm on Twitter where I do more of this, but in a smaller format. That's it. Beer. I'm gonna release you.
Thank you very much.
Thank you guys.